when you analyze very well, you will see that you have decision analysis topic, then you have linear programming, okay? And when you check on the required part A, they are telling us we advise this company's MD on the range over which opportunity costs, that is for direct wages, may apply. But you're going to determine range by using Simplex method. Remember, Simplex method is one of the methods we use when solving linear programming model. Part B is the decision analysis question, whereby you will be required to actually look for, so you will need the value of perfect information, compare it with the value of, with the cost of hiring a specialist, then advise accordingly. Can this company hire a specialist to do the work? So if you find that the value of perfect information is less than this figure, then you advise the company to actually not hire the market research specialist. Instead, they should do the work on their own. But that is not our focus for now. Our focus for now is part B. How can you use Simplex method? How can you solve a linear programming model using Simplex method? Then after solving linear programming model using Simplex method, you go ahead and get range. Range here, you need the lower limit and the upper limit, basically here. But whenever you say a question asking you range, this question must be corresponding to a certain constraint. You may be having one constraint or two constraints. Like now you have only one constraint, that is direct wages. So let's analyze. For purposes of our question, just when you observe the question, the paragraph that is going to help you to answer the question is this one, okay? Because already now you have linear programming model now. You don't need to again formulate the linear programming model. Already you have the model. So since you have the model, immediately start solving this model. Immediately start solving this model. So we are going to first solve this model using Simplex method. Then after that, we look for range, okay? So let's start. This was asked, this is a MDC question, December 2021. And our focus is about linear programming. So our focus is to use Simplex method, okay? Solve the linear programming model. That is number one. That will be our part A. Then part B, we will see how we can use our results to get range. How can you use your results to get range? So in this question, we are given our linear programming model. Okay, we have this is objective function. We have our objective function. Colleagues, you can also again draft this linear programming model again. So we have our linear programming model. Remember, if you don't have linear programming model, you're the one to formulate it. But a good thing here, we have our linear programming model. And when you check your decision variables are what and what? The decision variables in this question are just x and y. X represents what? Where x represent, your x represent in the question, represent data bundles. Then y you represent, this y you represent voice bundles. You have objective function in the question. Objective function, here the question is you to maximize profit. So you have Z max is equal to, Z max is equal to 500x plus 400y. Okay, but when you check, they are saying your figures are in millions. Okay. This is our objective function. But it is your objective function is subjected to the constraints. You have how many constraints? 1, 2, 3. You have direct wages, you have direct materials, direct wages, and overheads. Those are constraints. Okay. So here you have your constraints. Constraints, remember, colleagues, constraints are just limiting factors. Here we have direct materials. We have direct wages. Then we have overheads. For direct wages, when you observe, you have x plus 1.5y. Colleagues, are you in a position to hear me? Someone would confirm whether you can hear me? Someone okay. So we have direct wages, direct materials as the sorry, this is not equal signs. It is it less or greater? Which sign are they using?
We can hear you.
Okay. So this is the sign here used is less or equal to. Okay. It means that as the company, they have only 750 kgs for them to achieve. Okay, that's what is available. Then direct wages is 2x plus 3y also is less or equal to 1,500. Okay. Then overheads, these are workers. Direct wages, these are workers, colleagues. It means that the number of workers available are only 1,500. Okay. Then overheads, you have 2x plus y, and the amount available as overhead is shillings one so it is actually 1 billion, because when you check, we actually said shillings in millions. Then you have non-negativity. Non-negativity. And this non-negativity always based on your decision variables. You have x and y. All of them must be greater or equal to 0. The decision variables. Remember, I told you the reason why you need this non-negativity is that as you solve linear programming model, we don't expect you to be dealing with negatives. You have to limit that by formulating non-negativity. All values should be, the x value should be 0, y value should be 0 or above. You cannot get a negative value of x or a negative value of y. That's why this assumption is there. Okay. Once you have linear programming model, then you go ahead and now solve. We are solving this model, solve this model. We are solving this model using simplex method. And when you're solving the model using simplex method, we have the steps that we follow. We have the steps that we follow. You have your model, you must follow these steps. Step number one, step one, you must first introduce slack variables. Why are you introducing slack variables? You want to remove these inequalities and put equal signs. And these slack variables you are going to introduce will help you in the long run to know whether the company has fully utilized the resources available, or there are some unutilized resources. Okay. So how many slack variables are you going to introduce, Corey? If you have 3 constraints, it means that you're going to introduce 3 slack variables. If you have 4 constraints, you introduce 4 slack variables. If you have 2 constraints, you introduce only 2 slack variables. So here you're going to only introduce 3 slack variables. So you say let, you can say S, you can call it A, B, and C be the slack variables. For the first one is direct material. Next is direct wages. Then and the last one is overheads. Then you say respectively. Okay. So once you do that, you will now bring this. You will bring this here, but on every party you add a slack variable. Here we are adding a, then we say is equal to the slack variable a. You cannot again is equal to is equal to 750. Then also here you add B. For the next one, you add B and say this one is equal to 1,500. Then here you will add C and say this is equal to what? 1,000. So it means that here you have equations. This is equation 1. Here you have equation 2. Then lastly, you have equation 3. That is step 1. Step 1, you have introduced slack variables. And you are no longer dealing with inequalities, but now you are dealing with equations. Step 2, we formulate initial simplex tabulae. I hope you remember how we actually form. Step 2, you can say formulate initial simplex tabulae. That is step 2. Okay. So how do you formulate initial simplex tabulae? The first column, you recall, we put solution variable. Then we put product variables. And how many are your product variables? You have X and what? And Y. Remember, product variables, those are unknowns. Once you put your product variables, go ahead and put slack variables. And for slack variables, you have A, you have B, you have C. Then lastly, put column 4, solution quantity. That is your table. Remember, below the solution variable, we put our slack variables first, A, B, and C. Then last row, you put your objective function Z. So it means that we don't need this row. So how do you fill the table? X, now go back at your equations. This is row 1, this is row 2, this is row 3. Row 1, this is like your row 1. This is like your row 1, this is like your row 2, this is like your row 3, and this is like your row 4. Okay? So row 1 is this one. This is your row 1. Fill. Here you are going to put 1 because that is the value before X. Then here, where the value is, here you don't have B, you don't have C. Then you have 750. Row 2, you have 2 here. We are handling this one now. The value before X is 2. The value before Y is 3. The value, do we have A? No. We have B. We don't have C. Here we have 1,500. Then row 3, this is 2, this is 1, then this is 0, 0. Then this last row is your objective function. This is your objective function. Go back at your objective function and see what you have. The value before x is 500. This is 500. Then the value before y is 400. You don't have A, you don't have B, you don't have C, you even don't have the here any value after equal signs. Okay, so you have formulated your initial simplex tabulae. Once you formulate initial simplex tabulae, you go to step number 3. Step 3, colleagues, are we together on this point? For step 2, is it clear to you all? Is step 2 clear to you all? Colleagues, don't be very quiet. Eh? Oh, you are in parties, but putting on the session. Don't be too quiet. Eh? You may find for you guys you are in parties, but trying to follow. Step 3. Step 3, identify pivot row, pivot column first, and pivot row. Identify pivot column and pivot row. Okay, what is your pivot column? What is your pivot column? Pivot column is that column with the highest value on last row. Highest value of Z. So what will be your pivot column? When you observe here, this is your Z. Where is your highest value on this rows? On this row, the highest value is 500. So this will be like your pivot column. This one will be your pivot column. Then what will be your pivot row? Pivot row. What will be your pivot row? You do the working to identify the pivot row. You must do the working, identify. You must do the working to identify pivot row. And which kind of working are you going to do here? You come on your solution quantity, then remember this is your pivot column. Okay, so come to your solution quantity, divide each value here by the corresponding value on the pivot column. So you get this 750 divided by what is the corresponding value on your pivot column. Here, the corresponding value is 1. So we divide by 1. What do you get? You get 750. Here, you just be using your calculator. You don't need to do this. Oh, this is just like side work. Eh? Don't do this C. You just create this as a side work, or just use your calculator. Also get this, divide by what is the corresponding value. Remember the corresponding value, you're talking about the value on the pivot column. So the corresponding value is 2. Then here you get 1 divided by the corresponding value is 2. So ask yourself, after getting these values, don't do this, don't handle this. You only focus on where you have constraints. So once you do this, choose the lowest here. From these 3 values, choose the lowest. Here, this is your lowest value. And where you have the lowest value, that row will be your pivot row. So this will be your pivot row. This will be your pivot row, where you have the lowest value. Okay, so we have pivot row. This is our pivot row. This is our pivot row. This is our pivot row, and this is our pivot column. You have identified pivot column and pivot row. Then step 4. Step 4. Let me hope we are following. Colleagues, you are all following these steps. They will never change. Step 4. Step 4. Come up with the formulas that are going. Anyway, let me just say row operation. Not to waste time. Just call it row operation. Row operation here, you're trying to come up with formulas. But these formulas are going to help you to do what? The first formula you need to do under row operation, colleagues, first formula is make sure that you look at your meeting point where pivot row meets pivot column. We want to come up with a formula that is going to help us to make that meeting point to appear as 1. Where pivot column meets pivot, this is your pivot column, this is your pivot row. So we want to make that value to appear as 1. So which formula are you going to come up with? And where do you have that meeting point? In which row? You have that meeting point on row 3. So it means that you will need new row 3. New row 3 will be equal to what? New row 3 will be equal to the formula now. You want to make this value, this one you're seeing, you want to make this value, you want to make it to appear as 1. So which formula are you going to do? Always just get the original row where you have the meeting point, which row is row 3. Then divide by that value you want to change. That is the easiest way. You get where you have the meeting point, which row? It is row 3. Divide by the value you want to change. The value you want to see appearing as 1. Which value is that? The value here is 2. That's why I'm dividing by 2. So this is your first formula. And this formula basically is helping you to make the meeting point, to appear as one. And this is your pivot element. Okay. Then next formula, next part, when you're under row operation, you will need other formulas. Now, other formulas you're going to develop are going to help you to make sure that all other values on pivot column appear as 0. We want to see someone who is marking you. He or she wants to see the next table. He or she wants to see that this value is 0, this value is 0, this value is also 0. Pivot element 1, or the meeting point must be appearing as 1, your next table. So which formula are you going to come up with to make sure that this value appear as 0? And ask yourself now, this formula you are going to develop is for which row? This is row 1. So it means that you will need new row 1. New row 1 will be equal to the row you want to change, that is row 1, minus the value you want to change, which is 1, times your pivot row, which is new row 3. The row you want to change minus the figure you want to change times your pivot row, which will be this one. Now you will not be considering this. You will be using your new row 3. Okay, that is another formula. Then next, if you do this, if you use this formula, it is going to help you to make this value to appear as 0. And that's how you're going also to develop other formulas. New row 2 will be equal to new row 2. Now you're here. This is original row 2. Now you need a new row 2. So you will say the row you want to change, which is row 2, minus the value you want to change. Which value is that? 2. The value you want to change. Then times your pivot row, which is new row 3. Now you are done with row 1, row 2. Already you have new row 3. You don't need to again develop a formula. Already we have a new row 3. So it means that we can go to the next row, which is row 4. You want to make sure that this value appear as 0. So you will say new row 4 will be equal to the row you want to change, row 4, minus the value you want to change, which is what? 500. Then times new row 3. Or whatever you are doing here is to make sure that you get the value as 0 on the what? On the pivot column. Okay, so that is your row operation. That's how we develop the formulas. Colleagues, is it hard to develop these formulas? Is it hard? You just need to know the first formula you should develop under row operation is this one. You need to first make sure that the meeting point appear as 1. So come up with a formula that is going to help you to make that meeting point to appear as 1. So the meeting point is in which row? Row 3. So you will need a new row 3. Then get the original row 3 divided by the figure you want to change. Once you do that, the next focus is to make sure that apart from this point, this meeting point, which will appear as 1, I want to make sure that I come up with other formulas that are going to help me to make this value appear as 0, to make this value also appear as 0, also to make this value appear as 0. So someone who is marking you wants to see your next table with such kind of information. Here you must see 0, here you must see 0, here you must see 1 since it is a meeting point, here you must see 0. That's why you need to identify pivot column. The reason why you need to identify pivot row is that it is going to help you on this first point. Because without pivot row, you cannot know the meeting point. Any question about row operation, colleagues? Oh, it is clear. Please don't cram. If something is not clear, let me know, I can repeat. So let's proceed to the next step. Next step, step 5. Step 5 is to formulate another simplex tablet. We expect this next simplex tablet to be our final table. But sometimes you find that it is not the final table. Why? Remember, as you solve using simplex method, you started with initial table with the positive values here. So as you solve using simplex method, your aim is to make sure that the last values on your final table appear as negative values or 0 values. You don't want to see positive values on your final table. And the most focus is on the product variables. We don't want to see negative, rather, we don't want to see positive values on your final table. If you started with positive values as initial, on your initial simplex table, then the final result, we expect to see these values appearing as what? As negatives. You may be having other values, but other values appearing as what? Negative. The final table cannot be, the last table cannot be final as if you still have the positive values. For it to be a final table, these values on your product variable must be negatives. So let's see whether this next simplex table we are formulating will have negative values here. If they are not negative values, we will repeat the same procedures. Okay. So we can develop our simplex table. So you can draw this, but don't fill. We need to learn how to fill. Just draw and we You see how you can fill this one. Colleagues, these things cannot change. Just understand these steps very well. Now, once you do this, are you done with this? So that we can start filling the table together. Are you done?
Yes.
Okay, remember, you have the formulas here that are going to help you to fill this table. These formulas are going to help you to fill this table. So it means that this is like your new row 1. This is like your new row 1. This is like your new row 2. This is like your new row 3. Then this is like your new. And as you fill your next table, always start with the pivot row. That word is very key. Always start with the pivot row. Remember, what is your pivot row? Basing on these rows, what is your pivot row? Which row is that? Row 3, isn't it? This is your row 3. Start with your row 3. Because without this row, you cannot actually fill other rows. You see all other formulas have new row 3, new row 3, new row 3. So you cannot fill other rows minus this new row 3. So the formula is saying get row 3 divided by 2. What is your row 3? This is your row 3, the original row 3 is this. So how are you going to get the value here? You get the value that was here, the previous value that was here, exceed, this is 2, divided by the formula is saying you divide by what? By 2. And that's what you get. Then next you do the same. What is your original row 3 value? This is 1 divided by, the formula is saying you divide by 2. Next, you do the same. Is 0 divided by 2, you get 0. Then next is 0 also. Then C, what is the value, the original row 3? This is C, the original value was 1 divided by 2. Do the same here. The original value is what? 500? No, don't use this. We are using the original. Remember, this one, we are just going to help you to formulate, to know the pivot row. You are basing on these values. So it is 1000 divided by what? 2. So you're done with your pivot row. So once you're done with your pivot row, colleagues, to know whether you're going to repeat the procedures or not, I encourage you, I advise you, start with row 4 to know whether you are going to repeat the procedures. First, see, okay, before I continue, wait, before I continue, every time you find that here, you have 1 then the original slack variable that was here is going to change. It's going to change to x. Remember, originally we had the c here. This was the slack variable. But the fact that you have applied the formula, this one, when you are formulating a pivot element, the column that helped you to the column that has pivot element is going to affect the solution variable. So you see, this is where you have a pivot element, and that pivot element is on column X. So here you are going to put X. If the pivot element was here, we could put Y here. Okay, let me hope you have understood why I'm putting here X. Okay, so let's now also, this is Z, it will not change, it will always remain like Z. So you get, remember not to waste time, not to waste time. This formula that you were formulating, we are to help you to get 0, 0, also here 0. You don't need to do a confirmatory test. But if you want to do a confirmatory test, you just follow the formula. The formula is new row 4. Get your previous row 4, which is 500, minus open bracket. Colleagues, I hope you have the calculator. If you have the calculator, do what I'm saying. You will understand these things. Otherwise, for you, if you are just copying, you are not going to understand. For you, if you are just copying, you are not going to understand. So I'm saying on your calculator, put 500 minus, why are you putting 500? Because you're saying row 4. This is your row 4. What was the value here? 500. Then minus, open bracket. The formula is saying what? Put 500 times, the formula is saying you multiply by new row 3. What is your new row 3? At this point here, when you're standing here, what is your new row 3? It is 1, close bracket, then equal signs. Are you seeing that you're getting 0? Let me hope also on your calculator you are getting 0. You do the same here. The row here, this is the y. The original value of y was 400 minus, open bracket, 500 times, the formula is saying you multiply by new row 3. What is new row 3 here? At this point, when you're standing here, what is your new row 3? It is 0.5, close bracket. Are you getting this, colleagues? Colleagues, don't be quiet. Let me know whether you are understanding these things. Tell me why
Yes.
you are. Remember, we are not repeating these things again. So if you miss on this point, so this is A. I go back out and I see column A. Here I have 0 minus, open bracket. I put 500 times 500 times, what is the value here? It is 0. Okay, this is 0. I think also this is 0. Then here, equal signs, the value here, I'm handling which column? C. This is 0 minus, open bracket, 500 times times at this point, what is the value of C? 0.8. What is the value of new row 3? 0.5, close bracket. Then lastly, previously row 4, the value is 0 minus C, open bracket. Colleagues, don't forget to open bracket. Times 500. That's what I have. So the question is, are you going to repeat the procedure? The fact that you still have a positive value on your product variables, you will repeat the procedure. And once you say that you're going to repeat the procedure, you must be very fast. You must be very fast. So it means that here you confirm that you're going to repeat the procedure since you still have a positive value under the column, under columns for product variables. So it means that fill very fast this, fill very fast this, and repeat the procedure. And as you fill, of course, we are following the procedure, rather the formulas. New row 1, what is the formula? We get row 1 minus this. So I just get what is y here, 1.5 minus here it is 1 times what is your new row 3, 0.5. Do the same here, equals sinus 1 minus, open bracket, 1 times, what is the value here for new row 3, 0. Here, colleagues, those who are done with filling this, you can just tell me. B is 0 minus, open bracket, 1 times, this is 1 times 0. Okay, here, equals sinus, what do I have? 0 minus, open bracket, 1 times, what is the value of new row 3? 0.5. Okay, here, what do I have? The last row one, the previous row 1, it is 750 minus, open bracket, 1 times what is the value of new row 3? 500. This one is still, this is still. Now, sometimes you'll find that you are changing this to y. But I will talk about this. For now, first put this one. I will highlight on this when we are doing the next table. For now, first put, because here you're using the formula, the new formula is helping you to get, the value of product variable to appear as 1. And every time you use the formula and it helps you to get the product value appearing as 1, you change what you had this side. But I'm going to again talk about this later. Okay. Here, what was the value column for 3 minus, open bracket, 2 times 0.5. This one is equal to what? I'm handling what? Here, 0 minus, open bracket, 2 times what? What is new row 3? 0. Then here, B, column for B, the formula is, go back at your column for B. This is 1 minus, open bracket, 2 times what? Times 0. Here it is previous value 0 minus open bracket 2 times. Remember this 2 I'm talking about here is the 2 in the formula. 2 times the formula is saying you multiply by mu rho 3. So 2 times 0.5. Then lastly, I get 1,500 minus open bracket 2 times what? 500. So I'm done with filling in. So here you see that you don't have, you will still maintain the slacker variable that was here, which is B. So you're done with this step. And you see that this cannot be a final table since you still have a positive value here. We expect these values to appear as 0 or negatives for you to say that it is a final table. So next step, step 6. Step 6, repeat the procedures. Repeat the procedures. Procedures we are talking about here from step 3 to step 5. So this will be like now, as you repeat the procedures from step 3 to step 5, this table now will act as your initial. This will be like our initial simplex tableau. So this will be like our initial simplex tableau as we repeat the procedures. Remember, step 3 says what? Identify pivot column and pivot row. So what is your pivot column, colleagues? The pivot column is the pivot column is the column with the highest value on the last row. Last row is this one. The highest value is this one. So pivot column is this. Identify pivot row by doing the working aside. So we do what? We get this 250 divided by the corresponding value, which is 1. You get this divided by the corresponding value 2. Remember, we divide by the value on the pivot column. I get this divided by the corresponding value 0.5. So colleagues, what is the highest value? Or rather, what is the lowest value? Remember, pivot row is the row with the lowest value here. So what are you going to take as your pivot? What are you going to take as your pivot? What are you going to take as your pivot row? Now that's where you meet challenges in an exam. You know that my pivot row will always be that row with the lowest value. Here you get 2 values which have the lowest value. If you find that you are in this saga, what you do, analyze the question again on the required part and see which variable are they talking about on the required part. They are talking about direct wages. Ask yourself, direct wages as a constraint is in which row? This is row 2. So it means that as you decide here, the lowest value, go with row 2, because that's where your focus is. And the fact that now this is your focus, something must come. I'm going to talk about here, especially, remember I talked about this thing, this one. Okay. But let's develop now. We have identified this is our pivot row now. I can remove this now. And I say this is my pivot row, because that's where my focus is. So I'm done with step 3. I got step 4. Step 4 is coming up with row operations. So in an exam, you can just say here pivot column. Pivot column is which one? Column 4y. Then pivot row is row what? Row 2, row 3, row 2. In an exam. Then next row operation. Row operation now. Remember, row operation will start with what? Our focus is on meeting point. So to make sure that that value appear as 1. This is new. This is new row 1. No, sorry. Our meeting point is in which row? Row 2. This is our pivot column. This is our pivot row. And the meeting point is 2. We want to make this value to appear as 1. So it is new row 2 is equal to row 2 divided by what? By the value I want to change. What happens when you find that here you have the value as 1? What happens? If you find that you have this value as 1, you just, for confirmatory test, it will be row 2 divided by 1. Just will remain, because that value will be like 1. Eh? So it is that row divided by 1. And if the value now is 0, then you will need to look for another row. If that row cannot be your pivot row, if the value here, if the meeting point is 0, you will need to choose another nearest row, another nearest value to this. Because those things happen in an exam. You find that the meeting point is 0. The meeting point is 0, then you need to now, if you have, let's say here 253, you consider that one as your pivot row. Okay. What is our new row 3? Okay, here it is new row 1, new row 2, new row 3, because I already have new row 2. I will need new row 4. Someone's telling me what will be our formula here. New row 1. I'm waiting for you. Remember, this is your pivot column. You want to make sure that other values appear as. You want to make sure that this value appear as 0. You want to make sure that this value appear as 0. You want to make sure that this value appear as 0. Which formula should we put here? The row you want to change, that is row 1, minus the figure you want to change. Here it is 1 times your pivot row, which is new row what? New row 2. Then here, it will be the row you want to change minus the figure you want to change here, 0.5 times new row 2. This is row 4 minus the figure you want to change, which is 150 times new row 4. So you're done with step 4, forming row operation. Go to the last step. Colleagues, do that very fast. I'm waiting for answers. You now formulate the next another simplex tableau. You formulate very fast and tell me.
Abe,
Yes?
check the new row for it's row 4 minus 150 new row 2, not row 4.
Yes. This is new row. Yes, thank you. So we can do the same, formulate. We start with our pivot row, which is row 2. Following the formula. Colleagues, I'm waiting for you. Oh, you are also waiting for me. Hmm? So here the formula is saying, let me just put another. This is X, this is Y, this is A, this is B, this is C. So here the The previous value is 0 divided by 0. Here you get 0. Then here you get 2 divided by 2. Then here you get 0 divided by what? By 2. Then column 4b, 1 divided by 2. Column 4c, negative 1 divided by 2. Then lastly, it is 500 divided by 2. Confirm whether you're going to repeat the procedure. You first work on this last row. Colleagues, always follow these words I tell you. Otherwise, you'll be relaxed. Once you fill this pivot row, then immediately go and fill your new row, your last row. See whether you are going to repeat the procedure. Because once you see that you are going to repeat the procedure, even the way you write, the way you put some speed matters. So here, let's see. And another thing I want before you go to the next, colleagues, you see now, where you have a pivot row, where you have a pivot row, it overrides the original statement you made here. Remember, here you had y. This was your solution variable. Here we had a, we had b, here we had c. But because of pivot row, here we had to put x, because remember, after applying the formula, we actually see that we had 1 as the value here. So if you find that already you have y, but the formula that gave y is not anywhere as your pivot row, then you need to change your initial statement, because pivot row overrides your initial statement. As long as, let's say, this was, remember, this y was not as a result of this y being a pivot row. No. It was just as a result of seeing that actually, after applying the formula, I'm getting 1. Which is also okay. But the fact that this is not a pivot row, and now you have a pivot row that is actually even talking about your main focus, that is direct wages, it will override your initial statement. So it means that now you will need to make sure that this one appear as y. This one will appear as y. I repeat.
Yes.
Then this one will remain as x, because I'm saying, colleagues, you see here, the reason why we changed from a to b, rather from a to y. Remember, a is your slack variable, y is your product variable. And the reason why I actually included y here is because after applying this formula, the formula helped me to get 1 here. So every time I see 1 under product variable, I must change what I have this side. That is the first condition. Then the second condition is that If that formula that helped you to get 1 is not a pivot row, and along the way you're formulating, along the way you find that you need to repeat the procedure, and again you're formulating or you're getting the pivot row, ask yourself where you're getting pivot row. Was it the original pivot row or not? Remember, the original pivot row was which row? The first pivot row was in which row? It was row 3, isn't it, colleagues? So it means that row 2 has not yet appeared as a pivot row yet. And the fact that it has not yet appeared as pivot row, it will override what you stated. What you stated here. Because this one is subject to pivot row. This one is always subject to pivot row. Where you are changing a slack variable because of a formula, that one is always subjected, or it can be overridden by what? By your pivot row, in case it is there. I don't know whether you have understood. You cannot override again the pivot row. No, the pivot row will remain as pivot row. Let's say if at all we confirm that again this row is pivot row, we cannot again change this. No, because this was the result of pivot row. You cannot again change it. You can only change what you have here if there is a pivot row, and that pivot row is helping you to make the meeting point, n of the meeting points, to appear as 1. Here you may change this slack variable. That one is okay. So it means that once you do that, you proceed. So it means that now this one will be back to the default setting as A. Because we only have two product variables. If we have three product variables, before you again put A, you first wait and see, after applying the formula, are you getting 1? Because you may be having X, Y, and Z. So colleagues, let's not cram about these things. So before you put A, especially where you have X, Y, and Z, because now you have Y, you have X. These are product variables. But sometimes you may find that you have also Z. So if you have Z, Z has not yet appeared here. So you first wait and see, after applying the formula, where you have column for Z, is it appearing now as 1 or not? If it is appearing as 1, then you will put here Z. If it is not appearing as 1, then you will put here A. But here, like now, for our questions, for this question, you have only X and Y. It means that automatically, by default, you'll find that this will remain as A. So you find that, colleagues, people be knowing how to solve simplex method, but how to change this affect them. How to change this? You know how to formulate your operation, but how to change this can make you fail the final conclusion. Okay, so let's see whether we are going to repeat the procedure. Here, if you apply the formula, row 4, 0 minus 150. times times 0. Then here, row 4, 150 minus, open bracket, 150 times 1. Now I can be happy that I'm not going to repeat the procedure because I don't have a value that is below, that is above 0. Here, all I need is to see the value as 0 or as negative to say that this is a final tabule. So I can confirm that this is final tabule. I will not repeat the procedure. But you continue and fill, but you will not repeat the procedure, but you continue and fill everything. 0 minus open bracket 150 times 0. This is open. This is what? 0 minus. Colleagues, if you're done with filling some table, you can tell me values so that we go to the next very fast. Are you done with filling the table? Do you have these all the values? Someone can be handling this first row, as another person handles this third row. This is 150 times, because we'll be wasting time. This is, if you wait for me, this is C minus open bracket 150 times this. $150 times this. Me, I'm done with my row. Who is handling row 1? Are you done?
Me, I've handled row 3.
Tell me what is row 3. What is the value here?
1,
Next.
0,
Next.
0,
Pardon?
0, negative 0.25,
Next.
500.25,
500.
0.25.
Here, C, 500. Let's
No.
do this. Sign. This is C. I am handling which row? Row 3. 0.5 minus open bracket. The formula is saying once you open bracket, you say 0.5
0.75.
times what is your new row 3? Rather, what is your pivot row? New row 3.
It's negative
This is what I have.
0.75, yes.
What about the last one?
It's negative 250.
150. Negative.
125.
Here.
Yes.
Mm.
Negative 250, 125.
Let's repeat. equal sign. I open bracket. The formula is saying you get 0.5 times new row 2. What is new row 2? Here at this point to this one. This is what I have. It's not negative, because we don't expect negatives here for constraints. If you get a negative, know that you are wrong. Have you repeated using this your calculator? You repeat again and see whether you are getting this. Who is handling row 1? Who is handling row 1? Mabel. And you handling row 1? Sharon. Pardon? Please, if you do, you run your mistake. You cannot again fail. But if you wait to just copy, it will be hard for you. Let everyone try. Remember, we are following this formula to fill this row 1. Very slow. I don't know what is happening. Or you are fearing it talk. Do you have this?
Yes.
Okay, this is our final tableau. What does this one mean? It means that your value of X and the value of Y are the data bundles. What? You just analyze here. Y, X is this one. And then y is 250. And your maximum profit is equal to how much? Shillings at 287 500. Okay. If you want to know the unutilized resources, unutilized resource or slack variables you see that actually all are zero. You don't have C. Basing on your what? On your solution variable here. A is 0. You don't have B, you don't have C. So it means that everything is 0. So you don't have any unutilized resource. Okay, but the question is, can you get range? This is not your focus. Can you get range for opportunity cost? The question was not saying you get all this or no. The question was saying, can you actually get range for opportunity cost, but in line with direct wages. So what you're going to do when you want to get range, what you will do, you come here. This is your slack variables, okay? This is your slack variable. Where do you find which slack variable is talking about direct wages? Which slack variable? We defined the slack variables A, B, C, direct wage, direct materials, direct wage. So B is our slack variable corresponding to direct wages. And which column gives you? This is column 4B. Where is it here? So what you're going to do, stand here and start working out. Okay. You need to hear my words. You need to first know the variable you are talking about. It is direct wages. Go to the slack of variables, identify which column is for that variable. It is column B. Okay. Is column B. Then next, remember you are dealing with, you want to see whether there is an increase or a decrease. You want to get lower limit and upper limit, okay? So what will happen is, I just want to see whether it how I can make this one easier for you people. See. Okay. What you're going to do is where you see, are you seeing here this value 0.5 and negative 0.2? Because once you understand this, it will be all for us. Are you seeing 0.5 and negative 0.25? They are corresponding to y, and they are this 0.5 is corresponding to y, then negative 0.25 is corresponding to x. The reason why I'm focusing on these values is because they are my product variables. They are my decision variables. I cannot focus on this. I cannot focus on this. These ones are not my decision variables. So I will need to focus on 0.5 and on negative 0.25. Once you know where your focus is, I just want you to, the simple technique is, where you see a positive here, where you see a positive, where there is a positive, where there is a positive, that part, where there is a positive, it's an indication, it's an indication for a decrease. I just want to see the shortcut. Where there is a positive is an indication for a decrease. Okay. Then where there is a negative, it's an indication for an increase. Okay. Now, what does this one mean? Remember, we need upper limit and lower limit. So where you have a positive value, where you have a positive value, yeah, it will help you. It will help you to get upper limit. Wait. It will help you because here we are saying where there is a positive value, it's an indication for a decrease. So it will help you to get a lower limit. A decrease, it means that the original value is going to decrease. And now the new value will be your lower limit. What am I trying to mean? Okay, here. You're going to get, this is our positive value. So you're going to get, you stand here, where you have 0.5 as a positive. Let me hope you're hearing me. Where you have 0.5 on solution quantity, which value is there? You have 250. So you're going to get that 250. You get that 250. Divide by 0.5. What do you get? Is by 500. So what was your original? What was our original value of direct wage? We come back here. This is your direct wage. This is your direct wage. The original value is 1,500. So get that 1,500. We get 1,500 and subtract 500. What do you get? What you will get will be your lower limit, which is
1,000.
1,000. Now we have our lower limit. What about the upper limit? You are going to get the upper limit from this condition because we are done with this. This one is done. Where there is a negative, it's an indication for an increase. And since it is an indication for increase, it means that the positive value will help you to get upper limit. It means that the negative, it means that the negative value, it's an indication that where is a negative value, it's an indication that where we have a negative value, it will help you to get upper limit. Okay, so we do the working. We get, we come back here. This value, 3750, we divide by 0.25. What do you get? You get it. Okay. So once you get this, what was your original value of direct wages? The original value was what? 1,500. Then you add this one. We are adding this new figure. Which will be equal to, so in short, you're getting original value plus new value to get the upper limit. Here you are getting the original value minus the new figure to get the lower limit. So here you get 3,000. So upper limit, upper limit will be equal to 3,000. This implies that the range, now the range over which opportunity cost apply to direct wage is from 1,000, that is lower limit, to 3,000. And you are done. And you are done. Any question? So it means that here you are trying to bring in a range based on all your decision variables, not based on one here you are not basing on one decision variable. Here you are just trying to combine all of them. Okay? Yeah. Here you are trying to combine all of them. So colleagues, that's all for this question. This is question 2 that was asked in May Diet 2023. And part A of the question, they are saying we advise CEO of the company on whether a junior paste product should be divested using Simplex method. Of course, you are going to divest the product if it is not generating any contribution. So we need to see whether product junior paste product is part of the products that help the company to actually maximize profits or not. Then Roman part B, they are telling us that we advise this CEO of the company on the interval in grams within which opportunity costs apply for each scarce resource. Now you see this one, interval or range is based on each scarce resource. So you will need to ask yourself, how many scarce resources do you have? And you will know the scarce resources based on the slack variables. Okay. Then part C, the benefits of linear programming techniques. So it means that you need to analyze the question and see the information given. Like this one, they are telling us, here they are telling us that this company, a manufacturer of toothpaste, was incorporated, okay, in 2003. This company was incorporated in 2003, and it produces and sells 3 brands of toothpaste. So these are your decision variables. You need to define them. They produce junior paste, white teeth, and the doctor's paste. Okay. The contribution per gram. The contribution per gram. You need now to know that every time they talk about contribution, they are helping you actually to formulate the objective function. This is where you are going to formulate your objective function from. Remember, we can formulate objective function based on maybe the cost, based on contribution, based on the profit. It is always depend on the question. Okay. So if you're formulating your objective function, you are going to base on this. The marketing manager and the finance manager unanimously advised the chief CEO for divestment of junior paste, saying that it is generating lesser contribution among the 3 brands. They alternatively proposed the rebranding of the product as a way of renewing its life cycle. Okay. Below is the resource usage in the production of 1 gram of each. Now these are your constraints. Resources for you to produce doctor's paste, for you to produce white teeth and junior paste. You need the minerals, you need all that. So they are telling us here, the CEO is already having challenges of scarce resources because of existing suppliers for minerals, fluorine, color flavors, and labor hours, can only provide, are you seeing this word? The suppliers, when you observe this word, the suppliers can only provide this. So this is where you have inequality. You have this, this, and this, respectively per day. Remember, already you have minerals, you have mint, you have color flavors, you have labor hours. So you just need some, get this plus this plus this, so then put inequality. This plus this plus this, put inequality. This plus this plus this, put inequality. This plus this plus this, put inequality. As you put inequality, make sure that the value after inequality is corresponding to these values. And which inequality are you using here, colleagues? You are using, if suppliers can only provide this, which inequality are you using? Greater or less?
Less than or equal to.
Okay, yes. So that's what we have. Let's formulate linear programming model, because that's the information we have. Other things are just gamble. So we are going to formulate. Let's formulate linear programming model. One, we identify and define the variables. Let X, Y, and Z be, what is the first brand?
Junior Pest.
Junior just say number of grams for junior pest. Next is what?
White tape.
Hold on 1 minute. Let's analyze how our contribution is given. They started with what? They started with junior. We need to be very sober here. Here they started with junior pest, white teeth, and doctor's pest. But when you check down, they started with doctor's pest, white teeth, junior pest. So you need to make sure that at least you align in order, not to mess up. So I can I can call so that not to waste time. Let me call this one doctors, because any student can define. Can say X be white teeth, but you just need to just be strategic. And once you define it, don't change. Make sure that things correlate. Doctor's pest. Then next I call Y. I call Y to be white teeth, and junior pest, respectively. Okay. I have defined my decision variables. Then what is my objective function? Objective function. Objective function is going to be to maximize contribution. Z max is equal to I
That's
come
it,
back at contribution. Remember how you have defined X, Y, and Z. Follow this order. Start with doctor's paste, white teeth, and junior's paste in that order. So let's analyze the way contribution is. You see contribution, doctor's paste is the last one, isn't it? So
Yes.
this is 35 plus 35x plus
25,
25 plus 22z.
22Z.
This is 35y plus 25 25x plus 35x plus 25y plus 22,
22Z.
and these are shillings. Okay, constraints. Constraints, what you have minerals, you have ferment, you have color fibers, and then you have rubber. Then you will need non-negativity. Now we go back at our question. You see how we are given the data. Minerals, I am adding this plus this plus this. Then I say less or equal to what? I say less or equal to, are you seeing this data? I will say less or equal to this grams, okay? So you will tell me. We are getting 0.4x plus 0.25y plus 0.18z is less or equal to, is less or equal to what? 4,500? Is it? Yes, minerals. Remember, we are adding this plus this plus this, but less or equal to minerals. Minerals, it is corresponding to this because there is word respectively. So you must follow the order. Next, we go to ferment. 0.5 x plus 0.3, 0.3y. 0.3y is the same as 0.30y plus 0.2 z, but less or equal to, this one is less or equal to what?
5,600.
5,600. 5,600. Then this one is 0.2x plus 0.15 y plus 0.10 0 z, and this is less or equal to what? 2,400.
2,400.
Then here it is 0. Let me see. Is it 0.25 or 0.025? Okay. 0.025 x plus 0.015 y plus 0.01 z. Everything less or equal to what?
250.
Then non-negativity x, z is x, y, and z, all of them must be greater or equal to 0. That is your linear programming model. That is your linear programming model. Solve this by following the steps. From step one to step 5. You will solve this from step 1 to step 5. Okay? Step 1, remember, is to introduce Slacker variables. Once you introduce Slacker variables, step 2 is to form initial simplex tableau. Step 3 is to identify pivot column and pivot row. Step 4 is to state your operations, the formulas. Then step 5 is to form your another simplex tableau. Then you see whether it is a final tableau or not by looking at the values you have on the last row. If it is not the last or the final tableau, then you repeat the procedures using the same steps. But what I want to talk about is the final tableau. The final tableau will look like this, just final simplex tableau. After solving, you will solve. I want to see whether you will get it right. Let me give you the final simplex tableau to mark yourself. The final simplex tableau will look like this. This is solution variable. Then this is product variables. How many do you have in this question? You have X, Y, and Z. Okay, then you have Slacker variables. Okay, now how many Slacker variables will you be having? How many?
4.
They will be how many?
There will be 4.
Pardon?
There will be 4.
They will be 4 because we have 4 constraints. So I can say you will define your Slacker variables based on what you want. Let's say this is S1, and let me use A, B, C, and D. Then finally, you will have solution quantity. Okay, here this will be the final. Remember me, I'm giving you the final simplex. So you will have, this will be A, the final, this will be B, then this will be, let me see, this will be your Z. I'm giving you the final, then this will be your X. Okay, yeah, I will see whether you know how to change to come up with this. That's how it will appear. Then your contribution will be C. Here you can use C. If it is contribution, you can decide to call it C, or you call it Z, depending on what you want. Here you will be having 0. Here you will be having -8. Here you will be having 0, 0, then -400. Here is 0, then -400, then here 1,800, then finally -5, 110. Okay, then here you will be having 0, -0.02. Here you will be having 0, 1, 0, -1, -8, then 100. Here you will be having 600. Here you will be having 20,000. Here you will be having 2,000. Please make sure you do. Because I want to again talk about range. That's why I'm handling final simplex tableau. 0, 50, -200. Then this one, 1, 0, 0. Then this one will be also 0, 0, 0. Then here, this is 0, 1, 0. Here, 0, 1.5, 0. And here, it will be 0, 0, 1. So this is how your final tableau will look like. After solving, you will need, okay, this one, you will need to repeat the procedure, like the way we did the first one. You will repeat the procedure also once and come up with the simplex tableau. So once you have this, you will have this. You will have this, okay? So we need the range. All we need is range. Just that part A of the question, before you go to before you go to range. Part of the question they are saying, advise whether junior paste products should be divested. You advise the CEO of the company on whether junior paste products should be divested. So what you will do after doing this analysis, after coming up with this table, you are actually seeing that the only products company needed to maximize contribution is X and Z. But what is X? Basing on what you defined. X is what? Doctors paste. Then what is your Z?
That is junior paste.
Z is junior paste. And the company actually needed to produce how many grams for X? 2,000. Then Z, how many grams?
20,000.
20,000. These are grams. These are grams, okay? So the question is, should you, okay, here, this question, you don't need to produce, you don't need, it implies that here, you don't need to produce. Why? Why was what? Why T? You don't need it to produce. So it means that if the question is saying, should the company divest? Here you are not going to divest. The company should not divest this junior paste product. Why? Because with the production of junior paste product, the company will be in a position to actually maximize. The company will be in a position to maximize a profit of a contribution. Maximize a contribution. This is not profit. Contribution of shillings. How much? 510. With the production of 2,000 grams of doctors paste and 20,000 grams of junior paste powder. And the one, if you want to prove, you will prove by putting these values. You will copy your objective function, this one, where there is X. Let's first do and see actually whether my simplex final table is right. Where there is X, put 2,000, where there is Y, put 0, where there is Z, put 20. Do you get this? Let's see. 35 times 35 times X is 20 plus open bracket 25 times 0 plus 22 times 20. What do you get?
510,000.
You get 510. Eh? Okay, which which is the same as what? Which is the same as this. So you see that. So it means that the company should hold on to produce actually white teeth because of the current challenges of scarce resources. They should not divest junior pest. Instead, they should hold on to produce white teeth product since they will be in a position to maximize a contribution of shillings 110,000. Okay, so that is part A. Then part B, this is part A. Part B is to actually come up with interval, the range. Interval in grams within which opportunity costs apply. Within which opportunity costs apply for each scarce resource. The question is here, what are our scarce resources? What are our scarce resources? You will know scarce resources based on your slacker variables. If you realize that here one of your constraints has unutilized grams, remember you have 4,500 grams. Here you have 5,600 grams. Here you have 2,400 grams. Then here you have 250 hours. We want to see, do we have unutilized resources? And how do you know unutilized resources? You are going to come back here. Unutilized resources based on your final table. Based on your final table, unutilized resources. What are unutilized resources? You have A. You have A. You have also what? B. A is 100. Colleagues, are you in a position to hear me? Then here you have 600. These are unutilized resources. And if you have unutilized resources, these ones cannot be scarce resources. No. These ones are not scarce resources. So what are scarce resources? What are scarce resources? These ones are not scarce resources. Not scarce, not scarce. Because you have not actually even fully utilized them. So it means that your scarce resources are based on your slacker variables. C and what? C and D. C and D. Then ask yourself, what is C? What is D? Remember, this is A, this is A, this is B, this is C, this is D. So it means that here, color flavors and labor hours are scarce resources. Color flavors and labor hours labor hours are scarce resources. So you will handle one by one. You will get interval for color flavors. You get interval for labor hours because you have confirmed that actually those are your scarce resources. So we need to start with the color flavors. Then you ask yourself, color flavors are represented by which Slacker variable? Is represented by
Nice.
what is our Slacker variable?
C.
By C. Okay, in the final tableau. In the final tableau. Okay. Now we again apply our concept. The other concept I told you, this one. This one. Where there is a negative, where there is a negative, it's an indication of increase. Then where there is a positive, so okay, so let's analyze. You need to apply this concept to come up with your interval. Because the interval, with interval, you need upper limit, you need lower limit. And with this concept, you'll be in a position to actually know what is your lower limit, know what is your upper limit. So let's go back to our column C in the final tableau. Column C. This is column C. Then your focus should be where you have decision variables. No, that is not all that the focus. No, the focus should be now. What are you analyzing? What are we analyzing? Just come here. This is your C. You see here you have a negative. Just as whenever you see a negative, think about what? A decrease. Whenever you see a negative, think about positive, an increase, an upper limit. Whenever you see a positive, think about lower limit. Based on, we only focus on this. Okay? So here I am seeing a negative. So if it is a negative, I first identify, you handle one by, you can first deal with negatives or first deal with positives. We start with what, colleagues? We start with positive or negatives?
Negatives.
Okay, let's start with negatives. Remember, if your focus is about negatives, what are you interested in? To get upper limit or lower limit? If you are focusing on negatives, the focus here these ones all Here you are interested in getting the upper limit. Then with positives, you focus over. So let's start with the negatives. Let's start with negatives. Okay. Before we start with negatives, what is original value of the scarce resource we are dealing with of color flavors? What was our original value? The value after inequality.
It was
What was that value? The value after inequality?
2,400.
2,400. So what we need is the new value. So what is your new value? What is the new value? And how are you going to get the new value? Let's start with negatives. And as you deal with negatives, then it means that at the end you will get the original value plus the new value to get upper limit. So you will handle each go back at your solution variable negatives. Here you have you have we are getting 100 divided by 100. Rather 100 divided by 1. What do you get? You get 100. Because you see here in this question, we have many negatives. But in the first question, colleagues, in the first question, in the first question, when you observe this, I was almost saying I didn't do. When you observe this, I want don't start saying, what am I doing? You see in the first question, we had how many negatives? This one and this one. But you see this one where you have 0 this side. This should be not your focus. In a situation where you have 0 this side, this should not be your focus. But in a situation where you have a value this side, then you consider also this negative. Okay, back to this. I'm done with this. Get this one divided by negative. No, don't put a negative. Just get this divided by 1. Okay. Then next, where do we have negative? Here. X. And the value this side is 2,000 divided by 200. 2,000 divided by 200. What do you get?
10.
I get 10. This is negative. Okay, this is negative. Let's just put here. Okay, this will be negative. This. First, hold on. We go back to our table where we have negatives. It is 100 divided by -1. 100 divided by -1. You get negative what? 100. Then here it is 200, 2000 divided by -200. What do you get? Negative what? -10, eh? Okay. So among these ones, choose which one is the highest. Among these ones, which one is the highest? We have -100 and -10. So the question is, which one is the highest?
-10.
Okay. -10 is the highest. So what you're going to do is to get the original value, which is 2, which is 2, 4, then plus 10. What do you get?
2410.
You get 2,410.
Now, but why have you removed the negative?
Eh? Why?
Why have you
Okay,
removed the
okay, you
negative?
see, okay, you see the concept is, that's why I didn't want to bring in, because someone will, at the end of it all, you see, at first I had said you can decide to neglect what? Negatives. All what you need in your head is to know, okay, among these, because you see, if you don't put negatives, you end up taking 100 as the highest what? As the highest value. Are you seeing that?
Yes.
So the idea is, okay, I know that I want to choose the highest value. So if ideally, if you don't put negatives, you will end up choosing 100 as the highest value, which is wrong. So to avoid that confusion, I will do like this. But the fact that here I'm getting, remember, negative values give me the what? Give me the upper limit. So to get the upper limit, I need to get the value here. I need to get the value here, which is 2,400. Then I add the highest value between this one and this one. I don't consider the sign. The sign is just helping me to get the upper limit or the lower limit. Are you getting the
Yes.
signs just help you to get the upper and the lower? Okay. But let me hope we identified the right in a column. What column? Okay. Okay. Then let's see positive value. Let's see positive value. Remember, positive values are going to help you to get the lower limit. How many positive values do we have? Here, where you are going to get 0, 0, that one will not be considered. Are you getting that? The reasoning?
Yes.
Is 0. If you get this divided by this, you end up getting 0. That one you don't consider. Every time you say that you are getting 0, don't consider that. So it means that we only have 50. So we get 20,000 divided by 50. Here get, so this is upper limit. We need the lower limit. So get 20,000 divided by 50. What do you get? You get 400?
Yes.
So you get 400. Since this is 400, what will happen is, remember, this will help you to get lower limit. The sign is positive, so it should help you to get the lower limit. If the sign is negative, it helps you to get upper limit. So what will be your lower limit? You get the original value, which is 2,400, then minus the value 400. What do you get? Do you get 2,000?
Yes, 2,000.
This will be our lower limit. So the question is now, what is your range? The interval. We can say the interval for color flavor. For color flavor, color flavors is lower limit 2,000 grams to 2,410 grams. Are we together? Is this
Yes.
clear?
Yes.
So we are done with the first scarce resource. The next scarce resource, is what? And in your
Labor hours.
is represented by what in the table?
Mm.
Next scarce resource is labor hours, which is represented by which?
By D.
Labor hours represented by D in the final table. So we go our final table and stand. Now we are standing here. That's where we are standing. We start by identifying what we identified. We start with also negatives. Okay, let's
Yes.
start with negatives. But before we start with negative, what is the original value of labor hours? Original value, original grams. Original labor hours. Original labor hours. In the question?
It is 250.
250. Okay. So let's start with negatives and see. We have A, B, and Z. Okay. We have A, B, and Z. So here we are going to get the first one is 100 divided by -8. 100 divided by -8. What do you get?
Negative 12, sorry. Yeah, negative 12.5.
Then here next is 600 divided by negative 20. 600 divided by negative 20.
Negative 30.
Okay. Then next is what? 20,000 divided by, this is 20, divided by negative what?
400.
Negative 400. What do we get?
Negative 50.
Let me put here negatives. Let me put here negative. So the question is here, when you observe among all these values, out of these values, which one is the highest?
It is the negative 12.5.
So negative 12.5 is the highest, which will help you to get the upper limit. So you get 250 plus now you now negate, after knowing the highest value, neglect the sign. And what do you get? 250 plus 12.5. That's what I have. And this is my upper
limit.
limit. We do the same. We do the same for the next. Now we handle positives. How many positives do we have? We only have one positive value. So we get 2,000. Next, look at the positive value, which is basically, this is your x, okay? Log for x, get 2,000 divided by 200. Divided by 200. What do you get?
Ten.
I get 10. Since it is only one figure, if you have two or three values, you choose the lowest. Are we together? Here you choose the lowest. With positive values, you choose the lowest. With negative values, choose the highest. Okay, so what will be my lower limit? I get 250 minus 10, which is 240. And it will be my lower limit. Okay. And now you conclude. You conclude by saying the interval for labor hours is from 240 hours but 262, is it 262.5?
Yes.
That's how you handle. I hope it is clear. With the negatives, like here, choose the highest. After choosing the highest, add. Now neglect the negative, simply add. If you have many positives, then you will choose the lowest. Out of all the positive values, choose the lowest. And that lowest value will help you to get the starting point.